So let's recall what are those. Sine inverse. Or arc sine. Both are inverse. That is the inverse of sine. Then we have cosine inverse and arc sine. So I guess what we want to do is we want to find where derivative of sine inverse or derivative of arc sine. So let's recall what is arc sine or sine inverse. So we have a property that sine of sine inverse of x equals to x. There are some conditions here, assuming x is okay, because the domain of sine inverse is between -1 and 1. So let me remind you one more time what is going on. Sine inverse of x equals to y means sine of y equals to x. Okay, so what is happening is domain of sine becomes a range of sine inverse, and range of sine becomes domain of sine inverse. So that's why we have a thing here. Okay. So for example, there is no such thing as sine inverse of 2, so that's why there is no point of doing when x equals to 2. So anyhow, what we want to do is we want to find the derivative of sine inverse. So let's see how we'll proceed. Essentially, we're going to do the same thing as we did when we were looking for the derivative of natural log. We start with name calling. So let me move on to the next page and try. Call function sine inverse. Then we want to simplify expression. To simplify expression, we take the sine of both sides. Then expression on the right side, sine and sine inverse, they cancel each over. So we're going to get just sine of y equals to x. And at this point, we're going to take the derivative of both sides. We're going to take derivative of both sides. And on the right side, derivative of x is easy as 1. On the left side, derivative of sine is cosine. And because we're doing a chain rule times y prime. Solve for y prime, we're going to get 1 over cosine y. Doing back substitution, recall that y stands for sine inverse of x. So we're going to get sine inverse of x, derivative of equals to 1 over cosine of sine inverse of x. We're kind of done. The only thing which is left is to simplify the expression on the right. So if you look at the expression on the right, then what you wish to have is, we wish to have sine of sine inverse. So instead of cosine, we wish to have sine. So how we get that? So let's recall the main trig identity. Main trig identity says sine squared plus cosine squared equals to 1. Solve it for cosine equals to 1 minus sine squared. So cosine from here is going to be square root of 1 minus sine x squared. Okay. Then into that expression, instead of x, substitute sine inverse of x, and let's see what we're going to get. So cosine of sine inverse x equals to square root of 1 minus sine of sine inverse of x squared. So that becomes just x. So finally we have cosine of sine inverse of x equals to square root of 1 minus x. And that expression is going to be substituted here. So down the road, what we've got is the following formula, which says derivative of sine inverse of x equals to 1 over square root of 1 minus x. That's nice formula for derivative of sine inverse. We get the derivative of sine inverse. Exactly the same thing will be happening if we will take derivative of cosine inverse. And I'm basically going to be doing exactly the same steps. The only catch is going to be when we'll be doing the derivatives. The only catch is going to be when we'll be doing the derivatives. Somewhere at this point, we're going to have extra minus sitting up here. And that's the only difference. So we're going to have extra minus sitting somewhere, and that's the only difference. So we're going to get negative 1 over square root of 1 minus x. And that will be derivative of cosine inverse. So in particular, from here, it follows that we have one more table integral of square root of 1 minus x squared equals sine inverse of x plus constant. It also equals to negative cosine inverse of x plus constant, but usually we don't use negative cosine inverse of x because if we can deal without minus, then we'll rather deal without minus. We'll rather say it's sine inverse of x. So one more integral. So now let me try to use it once or twice and illustrate in a couple of examples how we'll do it. I'll start with derivatives, then I guess we'll see. If I want to take derivative of sine inverse of x squared, that is a chain rule. Derivative inside function is 2x. Derivative outside function is 1 over square root of 1 minus that thing squared, and that thing squared is x squared. So final answer is 2x over square root of 1 minus x. So go ahead, give a try to find derivative sine inverse of, say, e to x plus x. And ln of 1 plus sine inverse of x. Can you find these two derivatives? I'm going to give you a couple minutes to work on it, and then I'll try to catch up. Function for the first one is e to the x plus 1. Derivative of sine inverse is square root of 1 minus that thing squared, and that thing, in our case, e to the x plus x. Essentially, that's your answer. I guess only thing I can mostly do about it, put e to the x plus 1 on top. And square root of 1 minus e to x plus x squared. But it's not much of simplifications can be done. Second, derivative inside is going to be derivative of 1 is 0. Derivative sine inverse is 1 over square root of 1 minus x squared. And derivative of ln is 1 over. And essentially that's your answer. So we'll rewrite it as a one big fraction. But that's about it. So that's your answer for the second one and first one. So with derivatives, your regular product rule, quotient rule, chain rule, and two more functions to deal with, cosine inverse and sine inverse. Maybe just to make sure, I will ask you two more. Can you find derivative of sine inverse of x over 2 and derivative of sine inverse of bit more general setup x over 8? We ask to find by derivatives. Derivative inside x over 2 is 1/2. Derivative sine inverse 1 over square root of 1 minus x over 2. Essentially, we don't do derivatives, but we want to use some algebra to simplify that expression. So what we'll do, we're going to take these two and we're going to bring it inside of square root. If we try to bring it inside of square root, it becomes 4 because we will bring it inside under square root. So 4, we're going to multiply by 1 minus x over 2 squared is x squared over 4. Then they're going to distribute multiplication. You're going to get 1 over square root of 4 minus x squared. So that will be answer for this. And if you do the second one now, can you guess how the answer is going to look like? Or do you want to do calculations? I'm going to put dots here. Can you guess what the answer is supposed to be? Fraction 1, if you look at the pattern, square root. Can you see what's going to be under square root? Okay, so let's have a look. How we got 4 from x over 2? You see pattern? Actually, how we got 4 from 2?
You squared the 2.
We did square. So now we're going to square a. So we're going to get a squared. And we're still going to have x squared left because that's going to be same thing going on here And here it will be still canceled out. So that is one of the shortcuts which we'll be using for integrals. So shortcut for integrals will say something like integral of dx over square root of a squared minus x squared equals to sine inverse of x of a plus c.